Next, we tried to distinguish between weight and mass, and the distinctions we came up with were a little subtle, but they're very important. So weight is identical to the force of gravity acting on an object. It is Earth's pull on something. And of course, I guess this varies from planet to planet. You have weight on the moon because the moon has a gravity field, but it's going to be a little bit less since that pull is less. Now, mass, we got two definitions. Number one, it's the amount of stuff in an object, which, you can talk to a chemistry teacher about what that means. But in physics, we have a totally different, identical definition. Mass is a measure of, or rather, mass is totally equivalent to the term inertia, which is an object's resistance to being forced. And we actually watched a little Canadian video in which we described this inertia thing. And we're able to put all these ideas together. One last idea I wanted to put here is our key equation, which is that the force of gravity acting on an object is totally identical to its weight. That's not really an equation, that's just an equivalence, but I just wanted to kind of write that down. The second equation is that the force of gravity acting on an object can be found by the object's mass, and there's a factor that relates the mass to the weight, which is this letter G, which is exactly the 9.81 meters per second squared, or if you prefer, 10 meters per second squared, that we used previously when we were studying motion and acceleration and velocity and all that in our previous video. So what we finally ended up doing was putting all these ideas together into one big law known as Newton's first law, and it works like this. So objects at rest stay at rest. Objects that are moving stay moving in a straight line and a steady speed. If I see something speed up, slow down, or change direction, it is because an unbalanced outside force has made this happen. And this implies a couple of things that we actually discovered through the dry ice lab, which is that when you get something moving, it actually wants to stay moving, and nothing's required to explain once I've got it moving that it continues moving. In fact, if you see it stop, that requires an explanation, even though we see objects stopping moving every day, and that's because things like friction and other stuff like that act on it. So this is Newton's first law, and in the next video we're going to kind of go into drawing forces on objects and calculations.